Welcome to the lesson on compound interest. At the end of this lesson, you will be able to calculate compound interest and compare it with simple interest. You will also be able to deduce a formula for compound interest and calculate interest compounded half-yearly. Besides, you will be able to apply the formula for compound interest to solve problems on increase and decrease percent. Meet Mr. Smith and his daughter Alice. Mr. Smith is attracted by the 10% interest offered by a bank on 3-year deposits. So, he decides to open a savings account in Alice's name. He goes to the bank with Alice and opens an account. He deposits 15,000 rupees in her account.
Let's go home, Alice. Alice, do you know that interest is the extra money that a bank gives you for saving or depositing your money with them? Similarly, when you borrow money from the bank, you pay interest.
Yes, Dad.
So, can you calculate how much interest the bank will pay after 3 years?
Why not? My teacher explained to me how to calculate interest. Here, the principal is rupees 15,000, rate of interest is 10%, and time for which the money has been invested is 3 years. In other words, for 1 year, on a principal of rupees 100, the interest will be rupees 10. Then, on a principal of rupees 15,000, the interest paid will be 10 divided by 100 multiplied by rupees 15,000, that is rupees 1,500. Thus, the interest for 1 year will be rupees 1,500. Hence, the interest for 3 years will be 3 times rupees 1,500, which is rupees 4,500. So, the interest that the bank will pay after 3 years will be rupees 4,500. Right, Dad?
No, my dear. The bank will actually pay us more. They will pay an interest of rupees 4,965.
How did you get this, Dad? Where have I gone wrong?
You calculated it right. But a bank pays compound interest on the sum of money deposited. And you calculated simple interest.
Compound interest? How do we calculate it?
While calculating compound interest, the interest paid or charged is generally calculated on the principal plus the interest for the previous period. Let me explain this to you. Tell me, what is the simple interest for 1 year on rupees 15,000?
It's rupees 1,500.
Now, the amount that will be paid after 1 year will be rupees 15,000 plus an interest of rupees 1,500, which is rupees 16,500. This amount will now act as the principal for the second year. Now tell me, how much interest will you get on this principal amount?
The interest for the second year will be rupees 1,650. Right, Dad?
Right, Alice. Thus the amount after the second year will be the principal for the second year plus the interest. That is rupees 16,500 plus rupees 1,650, which is equal to rupees 18,150.
Now, rupees 18,150 becomes the principal for the third year.
Good.
Therefore, the interest for the third year will be rupees 1,815. And the amount at the end of 3 years will be rupees 19,965.
So after 3 years, the total interest will be the sum of interests at the end of the first, second, and third years. Therefore, after 3 years, the bank will pay an interest of rupees 4,965. This is the compound interest. Notice that compound interest calculated is more than the simple interest on the same amount of money deposited.
With simple interest, the interest is calculated on the same amount of money in each time period, and therefore, the interest earned in each time period is the same. In other words, the principal amount is the same for all the time periods. On the other hand, with compound interest, the interest is calculated on more money during each time period, and therefore, the interest earned in each time period increases. The principal amount increases for each time period as the interest payable is added to the principal. This means interest is not only earned on the principal, but also on the interest of the previous time periods. The interest is earning more interest. Wonderful, isn't it? Albert Einstein called compound interest the greatest mathematical discovery of all time.
What if you have to compute compound interest for a longer time period, say about 10 or 15 years?
It will be quite tedious and time-consuming.
Correct. That's why there is a formula to calculate compound interest. Let's derive it. Let us assume principal P is invested at a rate of R% per annum. Tell me the interest and the amount at the end of the first year.
Interest after 1 year is PR by 100. And the amount at the end of the first year is principal P plus the interest for the year PR by 100. Taking P as common, we find that amount is P multiplied by 1 plus R by 100.
Now, this amount becomes the principal for the second year. We now calculate the interest and amount for the second year.
Interest is equal to principal into R upon 100. And amount is equal to principal plus interest. Taking P multiplied by 1 plus R by 100 as common, we find that the amount after the second year is P multiplied by 1 plus R by 100 squared.
Now, this amount will be the principal for the third year. Calculating the interest and amount, we see that the amount after 3 years is P multiplied by 1 plus R by 100 cubed. So, this way we can find that after n years, the amount will be P multiplied by 1 plus R by 100 raised to the power of n. The compound interest earned will be amount A minus principal P. Can you now apply this formula directly to find the interest you will get on your investment?
Let me try. Principal is rupees 15,000 time period is 3 years, and rate of interest is 10% per annum. Substituting the values in the formula, amount is equal to P into 1 plus R upon 100 to the power n. We get A is equal to 15,000 into 1 plus 10 upon 100 whole cubed, which is equal to 15,000 into 110 upon 100 cubed. On simplification, we find that the amount after 3 years will be rupees 19,965, and the compound interest earned will be rupees 4,965.
Excellent, Alice.
Interest in general is calculated on a yearly basis. Sometimes it can be compounded more than once within a year. It can be compounded half-yearly, which means twice a year, or quarterly, which means 4 times a year. The period for which the interest is calculated is called the conversion period. At the end of the conversion period, the interest is added to the principal to get the new principal. The formula to calculate the new rate of interest with respect to the conversion period is rate of interest per annum multiplied by the number of months in the conversion period divided by 12. The formula for calculating the conversion period is number of years multiplied by 12 divided by number of months in the conversion period. Suppose a bank pays interest compounded half-yearly on the money you deposited. Then the interest you get will be different from the one compounded annually. Let us assume that Alice deposited 15,000 rupees at a rate of 10% per annum compounded half-yearly. This means that the rate of interest will be half of 10%, which is 5%. So, when interest is compounded half-yearly, the interest rate will be half of the annual interest rate. There are 6 half periods in 3 years. This means that the interest is compounded 6 times. Did you notice 2 times 3 is 6? When the interest is compounded half-yearly, the time period becomes twice. Now, let's find amount A, which we will get at the end of 3 years. Substituting the values of P, R and N in the formula, A is equal to P into 1 plus R upon 100 to the power N. We get 15,000 into 1 plus 5 upon 100 to the power 6. On simplification, we get 20,101.43 rupees. Therefore, after 3 years, the bank will pay an amount of 20,101 rupees and 43 paise if the interest is compounded semi-annually. This is more than the amount paid by the bank when the interest is compounded annually. So, when interest is compounded half-yearly, the interest rate will be half the annual interest rate, and the time period will be doubled. Urban population is growing at a rate of 1.5% per annum. The bacteria are multiplying at the rate of 3% per hour. Real estate prices have increased by 10% per annum. What do these statements have in common? Well, all the statements talk about rate of increase or growth. In such situations, compound interest formula can be applied to find the increase or growth. Consider this example. 2 years ago, the population of a town was 150,000. Its population has increased at a rate of 2% per annum. Population increase at the end of the first year is 150,000 into 2 by 100 or 3,000. Therefore, population of the town at the end of the first year will be population at the beginning of the year plus the population increase, which is equal to 153,000. Now, 153,000 is the population at the beginning of the second year. At a 2% increase, the population will increase by 3,060. Now, the population at the end of the second year will be the sum of the population at the beginning of the second year and the increase in population, which is 156,060. Therefore, the present population of the town is 156,060. Have you noticed that the calculation is the same as calculating compound interest? Let us apply the formula for compound interest to find the present population. Now, 150,000 will be treated as principal, the 2% per annum rate of increase as rate of interest, and 2 years as time period. Let A denote the present population. On substituting the values of P, R and N in the formula, we get the present population, which is equal to 150,000 into 102 by 100 squared. On simplification, we find that the present population of the town is 156,060, which is the same result that we obtained earlier. We can use this formula when there is a decrease too. We often find that the value of items like bikes, cars, televisions and machinery decreases over a period of time due to constant use and wear and tear. This reduction in value is known as depreciation. Can we apply the formula for compound interest to calculate depreciation or decrease in value? Let us see. Our friend Ron is fond of motorbikes. He bought a bike for 25,000 rupees. After using it for 1 year, the value of his bike has depreciated by 10%. To find the value of the bike after 1 year, let's find the reduction in value. The value of bike reduced by 10%, or by 2,500 rupees. Therefore, the value of the bike after 1 year will be 25,000 rupees minus 2,500 rupees, which is equal to 22,500 rupees. Let's try to apply compound interest formula and check if we get the same value. However, as the value is decreasing, we need to subtract the rate in the formula. Here 25,000 will be the principal and 10% depreciation will be the rate. We find that the value of the bike after 1 year is equal to 22,500 rupees, which is the same as the earlier result. We have seen that compound interest formula can be applied to solve problems on increase and decrease percent. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. In this lesson, you have learned compound interest and its comparison with simple interest. You also learned the derivation of the formula for compound interest. In addition, you learned to calculate compound interest when interest is compounded half-yearly and application of compound interest formula to solve problems on increase and decrease percent. this module, you will learn to calculate the difference between compound interest and simple interest. Ram and Shyam are business partners. They earned a profit of 50,000 rupees this year, which they divided among themselves equally. Ram invested his share of profit for 2 years in a savings bank account, for which the bank pays a simple interest of 8% per annum. Shyam also invested his share for the same period and at the same rate, but with another bank that pays compound interest. Who do you think will earn more interest, and by how much? Before you figure out the answer to this question, let us recall the formulae for simple interest and compound interest and derive a formula to calculate the difference. You know that simple interest is the interest charged uniformly on a given principal amount at a given rate throughout the period of loan or deposit. It is equal to P into T into R upon 100, or P into N into R upon 100, where P is the money borrowed or invested, called the principal amount. T or N represents the time period, and R is the rate of interest per annum. Compound interest is the interest calculated not only on the initial principal, but also the accumulated interest of the prior periods. Compound interest is the difference between the amount and the principal. If a sum or principal P is borrowed or invested for n years at R% per annum, then the amount is equal to principal multiplied by 1 plus R upon 100 whole power n. Since compound interest is the difference between the amount and the principal, it can be calculated by using the formula shown here. Now, Ram and Shyam invested the same amount of money at the same rate and for the same period. So the values of P, R and N while calculating the simple interest and compound interest will be the same. Let's now derive a formula to determine the difference between the compound interest and the simple interest when the time period is 2 years. The formula to compute compound interest is as shown. On substituting n is equal to 2 and simplifying, we get compound interest as PR square upon 100 square plus 2PR upon 100. Let's take it as equation 1. The simple interest on the same principal P for a time period of 2 years can be obtained by substituting T is equal to 2 in the formula for simple interest. On substituting T is equal to 2 and simplifying, we get simple interest is equal to 2PR upon 100. Let's take this as equation 2. On subtracting equation 2 from equation 1, we get the difference between compound interest and simple interest as P into R upon 100 whole square. Thus, when n is equal to 2, the difference between compound interest and simple interest on principal P at R% per annum is equal to P into R upon 100 whole square. On substituting the values of principal P, rate R in the formula, we get the difference between the interest earned by Ram and Shyam, as shown here. It is equal to 160 rupees. Thus Shyam earned 160 rupees more interest than Ram. Now, let's calculate the difference if they had invested the same principal at the same rate for 3 years. For this, we will first derive the general formula. The formula for compound interest is as shown. On substituting n is equal to 3 in the formula and simplifying, we get compound interest as shown. Let's take this as equation 1. The simple interest on principal P for 3 years can be obtained by substituting T is equal to 3 in the formula for simple interest. On substituting T is equal to 3 and simplifying, we get 3 PR upon 100. Let this be equation 2. On subtracting equation 2 from equation 1 and then simplifying, we get the expression as shown. Thus, the difference between compound and simple interest when the time period is 3 years is PR square upon 100 square multiplied by the sum of 3 and R upon 100. On substituting the values of principal P, rate R in the formula, the difference between the interest earned by Ram and Shyam is calculated as shown. It is equal to rupees 492 rupees 80 paise.